All right, this is APAB Calculus. We are doing the midterm review, and this is number 11 multiple choice, which means it is non-calculator. So the radius of a right circular cylinder is increasing at a rate of 2 units per second. So right away, I'm talking about a rate that something's increasing. This is probably a related rates question, just throwing that out there. So the radius of a cylinder is increasing at 2 units per second. So let's write down what that says. That says dr dt is a positive 2, right? And 2 units per second, but I'm not your science teacher, so I'm just going to ignore the units for a second. You can, your science teachers can be mad at me. The height of a cylinder is decreasing at a rate of 5 units per second. Well, if we write down what that says dh dt equals -5 because the height is getting shorter, right? Which of the following expressions gives, and then here's what we want, right? We want the rate at which the volume is changing with respect to time, and then they say in terms of R and H. What in terms of R and H means is that your answer is going to have R's and H's, right? So this phrase, in terms of R and H, this is a hint that your answer has these letters. You're not going to be finding a numerical value here. You're going to be finding these letters. So if we look at what they want in this situation, right? So the thing they want, right? This is the stuff that we know. They seem to want the rate of change of the volume. Well, that would be dV over dt, right? That's what they want. They want this, and my answer should have R's and H's, which fits because if you look at all the answers, they do. Now, they do you a pretty good solid here, and they give you the equation you're going to need, right? Because you can draw this if you want. It's not really worth it in this problem. I mean, it doesn't hurt if you want to know what a cylinder looks like, right? But this is a cylinder. They give you the equation, which I think is nice because admittedly we're all probably a little rusty at geometry. Now, the trap in this question is that this is a product rule, because there's nothing you can do to simplify the fact that this is an r squared times an h. You can put the pi with either of them. I always put the coefficient with whatever variable it is closest to. So I'm going to put the pi with the r squared. So when I differentiate, I'm going to get dv dt equals u, which is pi r squared, dv, which is going to be a dh dt, plus v, which is going to be an h, and then du is going to be 2 pi r dr dt. And at first this looks kind of disgusting, but realistically, if you look, you were given dr dt. Oh, wrong color, my bad. You were given dr dt, right? And you were given dh dt. So we know these values, and if you look at my answer, all of these answers up here have r's and h's because that's what we were told. So if we substitute in, I'm going to get the dv dt equals a pi r squared times a -5, so -5 pi r squared, right? And then a 2 pi rh times a 2, so that's a 4 pi rh. And so this is my answer, and then it's just a matter of picking the answer that matches. And sure enough, I want this one, right? Because it's a negative in front of the pi r squared. All right, and that's it.